What's the one thing that is common between the winter sports enthusiasts, snow and winter Olympic Games? That's right, snowboarding. If you have tried snowboarding, you must know that it isn't as effortless as it looks, and the construction of snowboards is pretty much the same, because there is more to the process that meets the eye. What goes into the making of these snowy surfboards, and how difficult is the process? Keep watching to find out. Step 1. Selecting the snowboard materials. Let's start with the inner workings of what makes a snowboard. There is no secret formula to snowboard design, just 3 essential parts: base, core, and glue. So let's start with the base. For snowboard's base, we use a plastic base, PTEX, also known as ultra high molecular white polyethylene, or PTEX. It is a highly durable, dense, and abrasion resistant thermoplastic, making it easily repairable should you ding your base on a rock. The best part about PTEX is that it openly accepts wax in order to improve its gliding efficiency, depending on the variety of snow conditions. Once we're done selecting the board, it is time to pick up our core material. Now, it's important to remember that core is the most crucial component of the snowboard, since the remainder of the board will be constructed around it. Since it's the center of the snowboard, the core's material must be chosen carefully because it determines the characteristics of a snowboard. Usually, cores are mostly made of laminated hardwood strips, such as birch, beech, aspen, bamboo, poplar, and opshi. We go for wooden cores because wood helps retain the shape, enables good vibration dampening, and has less resonance when it compares to plastic or foam cores. However, some companies use other core materials, like foam or aluminum honeycomb, to create variant flexes. In fact, there is a wide variety of core materials, like carbon, which is strong, high strength, and very good under compression, or Kelvar, which is incredibly light, a good dampener, and also good under tension and lightweight. Now, the top sheet of the snowboard requires more deliberation. It's made of several materials such as wood, fiberglass, and plastics. The best option is fiberglass because it improves the board's stiffness and ensures that the board does not deform. It lies right on top of the core and allows the snowboard to bend more easily. It's also an inexpensive choice as compared to alternative top sheets. Now, what are we going to use to hold everything together? For this purpose, we'll use resin as glue. Remember, the glue used in snowboards is pretty universal. You will need a high-end 2-part epoxy or resin combination that will withstand freezing temperatures. Alright, so now that we're done with the basics of the snowboard, base, core, and glue, what about the other stuff that helps to run everything smoothly out on the snowboard slopes? This includes the edges, inserts, sidewalls, and most importantly, dampening. Plastic piece sidewalks are commonly used in snowboard construction because of their high strength to weight ratio. On the other hand, the edges are made of stainless steel and they are fixed using T-shaped inserts. The edges are usually bent to the shape of the snowboard and then glued into the base. The stainless steel inserts are inbuilt into the core of the snowboard to screw bindings into. Lastly, we need a dampening material along the edges. This material is like a long thin rubber that will absorb all the chatter. Once we have selected the subtone materials for our snowboard, it's time to start the construction process. And first up is, of course, preparing the core of the board. Step 2. Preparing the core. We start with the core of the board. Snowboards' cores are usually made of thin sheets of wood laminated together either vertically or horizontally. Pine, birch, bamboo, maple, and aspen are popular core choices, but it totally depends on the type of snowboard you want. Usually the manufacturers use 2x4 pieces of wood that are glued together. After that, they are stacked up into what will become the width of the core. The thicker the wood, the stiffer the wood will be. But the core can be planned down to varying thicknesses for different flexes in order to make it less rigid. In fact, some companies add a sheet of fiberglass to the bottom and the top of the core, so they can keep the cores as thin and lightweight as possible without breaking under tremendous pressure. Once we have prepped the core, bindings will firmly be attached to the board. Step 3. Drilling. Now it's time to drill holes into the cores for inserts. This will allow us to secure the bindings later on. In order to make the drilling process more precise, a template is used so all the holes will be identical. But we're still not done with the board, so let's get to that. Step 4. Planning. In this step, the thickness of the board is reduced to the required level because, obviously, a thick board will be too stiff and rigid, so planing reduces the unnecessary thickness of the wood until we obtain a light, thin board. Step 5. Shaping. Moving on, it's time to make the board more shapely, because right now, it's just a rectangular plank of wood with zero curvature. It's perfectly flat at this point, so a shaping procedure will refine the contours of the board. Once the board has been shaped, it will be stored upright before the next process. Step 6. Adding aluminum inserts. Inserts are added into the core to screw bindings into. These aluminum inserts will be embedded into the wooden core. The thin fiberglass sheet will provide a better surface for the inserts and thus more solid support. It's important to remember that clamps must be used to keep the board securely held in place. Now it's time to glue everything together. Step 7. Applying epoxy. All snowboards need a high-end 2-part epoxy and resin combination that could withstand frigid temperatures. Epoxy is a powerful adhesive and is applied to fiberglass at room temperature, but since the excess glue can spill everywhere, it's vital to get rid of the excess epoxy in all air bubbles to ensure good adherence. Step 9. Silk screening. Alright, so now that we have the plain board now, it's time to add a splash of color. Silk screening will be used for the top sheet of the board. Ink is spread all over with a little squeegee, and colors have been applied once at a time. Another method to get a more RC base is by taking a clear base and putting a graphic underneath. Some companies also use a sublimations printing process. This is a heat transfer process that can only be done with a sintered base. Once the colors have been applied, the ink must be allowed to dry for a couple hours before another coat. Step 10. Curvature of the board. Since the board is flat, we need to add some curvature to give it that signature snowboard look. A cover will be placed on the mold, and the mold will then be closed. This will give the board the desired curve. After the board comes out of the press, it has excess epoxy all over it. Now we need to make it presentable. Step 11. Bandsawing. Due to the heat trapped in the mold, the epoxy has set and solidified. It needs to be removed to make the board presentable. Additionally, edge, tips, and tails need to be ground down and polished to get rid of all the excess glue. For this purpose, we'll use a bandsaw. The saw blade is changed after every 50 boards, so make the perfect cut. This step is manual and highly precise. Step 12. Varnishing. Now it's time to add a coat of protective varnish to the board. A thin curtain of varnish will flow down as the board passes beneath it. Once the board has been varnished to perfection, it will be taken to a dryer for another 6 hours. But there is still one step left that will add the final touch to the snowboard. Step 13. Sanding. In the final stage, the board will be sanded down. Sanding removes any excess glue and surplus varnish from the board's edges. Once all the imperfections have been removed from the hardened varnish, the new holes will be drilled into the board to locate the inserts installed at the beginning of the production. After that, a second varnish coating will be applied to the board. Once that is done, the plastic base will be sanded to obtain the desired finished board. Finally, a razor blade will verify that all the different coats perfectly adhere to each other. Now all that is left to do is wax, sticker, package, and ship the snowboards to all the winter enthusiasts who ordered them. Click one of the 2 videos on the screen right now.